Everyone, a lot of you have been really trying this assignment out, and you're doing a fantastic job. I wanted to talk about a couple of problems on here that have been giving you guys some fits. So I want to talk about numbers 3 and number 4, particularly 4B. Okay. So first of all, talking about number 3. If you don't need this one, you can just fast forward to the part you need, but just thought I'd give you a little bit of help on this so you can master this assignment. Remember, number 3 and number 9 are similar, so you can use this to help you on number 9. So on number 3, we talked about how if we're covering everything except the circle, we're going to do the surface area of the prism minus the circle's area. Okay. So for the whole prism, remember what we have here. Surface area is area of all the surfaces. So for a rectangular prism, that would be the front and the back are the same. So the front and the back, if we look at this, if I highlight that, would be, this is the front, right? So for now, we'll just ignore that the circle's there. So for the front, that would be the rectangle made up by this side and this side, which is 7 by 4. Okay, 7 by 4. So 7 times 4 would be the area of the front, and there's also a back to go with it, so times 2. Some of you are multiplying by other numbers, but that times 2 is because there are two rectangles. There's a front and a back, and there's only 2 of those. All right, let's talk about other rectangles. We've got this one here, right? This one here, you'll notice we've got 4, that's this length here, by 2, this length here. And this is the right side. Well, if there's a right side, there's also a left side. So our 4 by 2 would also get multiplied by 2. And then we're going to add all those surfaces together. So far, if you look at what I've highlighted on my screen here. Let's watch too. You look at what I've highlighted on my screen here. I've got the left and the right taken care of, right? So I took care of this. I took care of this, right? The front and the back. I've got to take care of this up here. So that would be a good color. This rectangle right here, okay? Which its dimensions are 7, and this distance here, which is 2, if I bring this up. So 7 by 2 for the top and the bottom, plus 7 times 2, and there are 2 of those. So for the surface area of the whole thing, I have 28 times 2, because there's a front and a back. I have 8 times 2, because there's a left and the right. And I have a 14 times 2, because there's a top and a bottom. So all told, 56, 16, and 28, minus the circle's area. Now the circle in 3 and 9 is just on the front. You'll recall area of a circle is pi times radius squared. We memorized that formula in the first half of the chapter. There's no new formulas here. For the radius of the circle, that's the distance from the center out. Well, it would appear we're in trouble unless you realize that that distance is the same no matter which way we're going. So if you look at this circle, you see that it's positioned so it's from the top of the prism to the bottom. So this distance here, going all the way down, that's the diameter. So the diameter is 4. If diameter is 4, then the radius is half of that. All the way across is 4 centimeters, halfway across is 2 centimeters. So we're going to do pi times 2 squared. All right, I'll start by adding all this up. Oh man, I don't have my calculator, it's early. So 72 and 28 makes 100, I think. Let me just check that real quick. 50, 10, and 20 is 80. 80 and 12, 92 and 8 is 100. Good. All right. pi times radius squared. This pi times 2 squared, 4 times 3.14 is 12.56. So my final answer is 87.44 centimeters squared. Hopefully that helps you to do number 9 as well. Okay, number 9, come over here. Oh, there it is. Number 9, it's a triangle, not a circle. And we're doing meters, not inches. Remember, we fixed that typo in class. Number 9, you're doing the whole surface area minus this triangle on the front. So same kind of approach as number 3. So we'll see what you can do on that. 4. All right, number 4. Because I did, just to save time, because I did this part, okay, when it talks about the block being painted, okay, and how much paint do we need, that is surface area. So all you're doing in part 1 is surface area of this prism right here, okay. So that shouldn't be too bad. I've got a front and a back, okay, and the front is 5 by 7. I've got a left or a right side and a left side, and that's 2 by 5 times 2, because there's 2 of them. And then I got a top and a bottom. The top is 7 by 2. Notice how I'm dragging my finger along the rectangle that makes it, and that helps me figure out the length of those sides that are making up the rectangle, base times height, right? So I'm going to leave you to do part A, because not many people are struggling with that. What people are struggling with is 4B, and conversely, or similarly, I should say, 4B is the same thing as 7B and 11B. Now, for those of you who weren't paying attention in class, we already did this, or maybe you were just absent. This we're going to combine. You'll notice we are cutting the object. So this is like slicing 3D shapes. We're looking for the area of the cross section. Look at the question is made. The question says. So a couple things here. When the cut is made, 2 prisms are formed. So we're going to talk about the cut in a second. We form 2 prisms, and the question is, what is the area of the surfaces that are not painted? We remember back in part 1, we painted the outside of this. So what's not painted? The inside, right? So when I make the cut, I'm exposing an unpainted surface. We need to look at what shape that is so that I know the formula I need to find the area of it. So let's talk about how it's cut. The cut is made along the diagonal of the front face. And that front face is 5 by 7. So that would be this one right here. Okay, so it's made along the diagonal. Diagonal means from corner to corner. Draw this on your paper. I have a lot of you trying to do this in your head, and it shows because you're getting the dimensions wrong. So along the diagonal would be this line right here. But that line is not the only part of the cut. Remember, this is 3-dimensional. So when I cut this direction, I cut like this, it's not just going from corner to corner, it's going through the whole shape. So it's going to enter on the back side here and exit on the front side here. Those are entry and exit cuts. And while it's cutting down the center here, down the diagonal here, remember the other part of the blade is hanging out the back. So right now, you should be able to see the 2 prisms that are formed. When I pull this apart, I pull this part this way and this part down. I'm going to form 2 triangular prisms, okay? And so then the shapes that are not painted, those cross sections that are exposed, are these rectangles right here. I say rectangles because there will be an unpainted rectangle on the top prism and an unpainted rectangle on the bottom triangular prism, okay? Now we have to talk about what the dimensions of this rectangle, what those dimensions are. It's this distance times this distance, okay? And this distance, all right, be careful. I've got a lot of you messing up that distance on 4B, okay? So the base of this rectangle will be 2, right there, right? The question is, what is that distance there? Well, it's not 7, because you'll notice 7 is not on the actual drawing. It's also not 5. 5 is not on the actual rectangle, okay? It's the length of this diagonal, which if you're reading, the length of the diagonal is written right here. So you need to take that and draw an arrow up like that, all right? This drawing I put on here, I want to also see when you do 7b and 11b. So this rectangle would be 2 times 8.602. Okay? That's the length of the rectangle. Now remember, we have 2 of those. So because there are 2 of those rectangles, we do times 2. So one rectangle is 17 point, again, it's early, 204, right? But I have 2 of those rectangles, one on the top prism, one on the bottom prism. So we double the area. Our final answer is 34.408 centimeters squared, because it is area. So when you go to do 7b, draw the cut on there. Don't try to do this without drawing the cut. It's along the diagonal. So we cut like this. So it's that distance is part of the cut, and then we go here, out the bottom, out the top, cut along the back. Some of you are saying that this base here is 2. It is not, as you can clearly see. It is not 2 meters. You're what we call overgeneralizing. You're multiplying this diagonal, right? This diagonal, you're multiplying by 2 because that's what we did in 4b. That's not why we did that, okay? It's the area of the rectangle is this distance times this distance. You need to figure out what that distance is. And you can, I'm not going to say it because you can see it. You guys are bright kids. I wanted to talk also about number 6, because some of you are missing 10 and 12. Remember, we did number 6 in class. So again, for those of you not paying attention, or those of you who were absent, you'll remember here we are wrapping several cubes. Wrapping means surface area, okay? And the fact that it's a cube means a couple of things. Okay, yeah, I know it's 2 feet high, but think about what a cube is. A cube is made up of 6 faces. Let's just write this down. Cube. It's got 6 faces. And think about what each of those faces are what shape they are. They are 6 squares. So if the height is 2 feet, that means the width is also 2 feet, or the base. So our cube is 2 by 2. Remember, it's 3-dimensional. So to wrap one of the cubes, or one of the faces of the cubes, is just 2 times 2. But because it is a cube, there are 6 of those squares. So 2 by 2 is the area of 1 square. We have 6 of them. So we multiply by 6. And that tells us it's 24, let me look at my labels, feet squared of bubble wrap to wrap 1 cube. Well, then look what the problem says. The problem says she uses a total of 120 square feet. Well, each cube she wraps is 24 square feet, so we will just then take 120 and split it into groups of 24 to figure out how many cubes does she wrap. That would be 5 cubes. Okay? So it's the same kind of thought process on 10 and 12. Got to find the surface area of one of them in order to find how many that were wrapped. If you have other questions, please email them to me. But that should definitely help you to get 3 out of 3 on your homework. Good luck.